Hello everyone, this is Shankar. In this video, we will discuss control systems questions given in recent GATE 2024 exam from EC paper, Electronics and Communication paper. Now let us go into the video. The first question given in the exam is 1 mark question MCQ. In the context of Bode magnitude plots, 40 dB per decade is same as. It is a straight question, no need of any explanation. But if you just recollect, in the decade scale, 20 dB per decade is equivalent of 6 dB per octave. 40 dB per decade is equivalent of 12 dB per octave. Therefore, option B is the correct answer for the question. Now, let us look into the next question. This is also 1 mark question. It is an easy question, but there is a slight twist in the problem. In the feedback control system shown in the figure below, forward transfer function g of s is given, that is 1 by s into s plus 1 into s plus 2. Notation is same, r of s, y of s and e of s are the Laplace transform of input, output and error function respectively. Now, if the input r of t is unit step function, then which option is correct? By seeing the options, it is asking about steady state error. Now, in this case, even though it is a type 1 system given step input, let us check one condition. Steady state error definition is applicable only for stable systems. For marginally stable system and unstable systems, final value theorem cannot be applied, hence you cannot determine stability. So what we will do, first let us find out what is the characteristic equation. So that is 1 plus g of s is equal to 0. So what is that? 1 plus 1 by s into s square plus 3s plus 2 is equal to 0. Now, s cube plus 3s square plus 2s plus 1 is equal to 0. Now, for this particular characteristic equation, you can easily find out that roots are, there will be 3 roots. Roots are at, one root is at -3 and remaining 2 roots are at plus or minus j root 2. That means there is a root pair located on j omega axis. Therefore, the system is marginally stable. For marginally stable systems, the response will be, step response will be oscillatory. For oscillatory systems, steady state error does not exist, or you cannot define steady state error. Therefore, for this question, option C is the correct answer. Now, let us look into next problem. This question was given for 2 marks as an MCQ. A satellite altitude control system as shown below has a plant with the transfer function g of s is equal to 1 by s square. So, this is the plant with a compensator. Now, compensator is given here. Okay. Transfer function for compensator is k into s plus alpha divided by s plus 4, where k and alpha are positive real constants. In order for the closed loop system to have poles at -1 plus or minus j root 3, what is the value of alpha? You have to find alpha value. So, what I can do now, first with the given plant and transfer function, let us find out characteristic equation. Characteristic equation is 1 plus C of S into G of S is equal to 0. You can also have one more observation. The plant is given type 2, okay, type 2 plant. Type 2 plant means the poles of the closed loop poles will be at j omega axis. That means the system is at marginally stable system. Therefore, for the system to be stable, or in order to stabilize the system, we must use lead compensator. Then only the root locus diagram will be pulled into left hand side of the S plane. Therefore, you can say that C of S must be lead compensator. Lead compensator means alpha should be less than 4. Even all options are given in the same way. Now let us try to find out. Okay, so 1 plus characteristic equation 1 plus C of S is K into S plus alpha divided by S plus 4. This is a compensator multiplied with 1 by S square is equal to 0. Now from this equation you can simplify S cube plus 4S square plus K into S plus K alpha is equal to 0. S cube plus 4S square plus Ks plus K alpha is equal to 0. Now let us call this equation as 1. Now by observing this characteristic equation, you can immediately understand it is a third order equation. Therefore, there must be 3 poles. But in the question statement, what is given? After compensator, the required pole location only 2 poles are given, that is -1 plus or minus j root 3. That is a complex pole pair is given, or you can also understand that can be dominant pole. So real and imaginary pole location, if you draw this pole plot, this is a -1 plus j root 3 minus j root 3. Now we don't know where is the third pole is located. Then what I can do, hypothetically let us assume that third pole is placed at -a position. Therefore, with this required pole location, now I can define required characteristic equation. Required characteristic equation is S plus A multiplied with the given complex pole location, I can write it as S plus 1 whole square plus root 3 whole square is equal to 0. Then it will give you S plus A multiplied with S square plus 2S plus 1 plus 3 will give you 4 is equal to 0. Now let us multiply S cube plus 2S square plus 4S plus AS square plus 2AS plus 4A is equal to 0. Or you can also write it as S cube plus 2 plus A into S square plus 4 plus 2A multiplied with S plus 4A is equal to 0. Now this is the characteristic equation as per the pole location, as per the required pole location. Then what you can do, by comparing equations 1 and 2, you will get, now start with S square coefficient. So if you take S square coefficient here, S square coefficient in equation 1 is 4, in equation 2 is 2 plus A, then it will give you A is equal to 2, 4 minus 2. Next, by comparing S power 1 coefficients in equation number 1, that is k, in equation number 2, that is 4 plus a. Okay, that is a 4 plus, I am sorry, 2a. Therefore, you will get k value is equal to simply 8. Now, if you compare constant terms, in equation number 1, constant is k into alpha, k into alpha. In equation number 2, constant is 4 into a. Therefore, k value we got 8 into alpha is equal to 4 into a value is 2. Then the answer will be 8 by 8, that is 1. So, with this calculation, the correct answer for the given question is option D. It is simply 1. Now, let us go to another problem. This is the question number 4, or question number 4 in our video. In the exam, the question number is something else. Now, consider a unity negative feedback control system with forward path gain g of s is equal to k by s plus 1 into s plus 2 into s plus 3 as shown in the figure. Now, the impulse response of the closed loop system decays faster than e power minus t. What do you mean by that? So, in case of the response should be faster than e power minus t means, what is the basic requirement? The dominant poles of the system should be less than minus 1, okay, or left hand side of this minus 1 point. So, anywhere the dominant poles can be located left side of this minus 1. So, in order to check that, you have to find out relative stability concept. So, what I can write down here, dominant poles should be left side of, dominant pole should be left side of minus 1. In order to find out that, in the characteristic equation, you should replace s with some other variable, let us say that is z minus 1 is equal to 0. Now, for this new equation, you apply Routh's method, Routh's table, and then find out the condition for stability in the new variable. Let us see that. Now, here 1 plus g of s is given as k by s plus 1 into s plus 2 into s plus 3. Now, here replace s with z minus 1. Then what you can write down here, 1 plus k divided by z into z plus 1 into z plus 2 is equal to 0. So, with this, you will have characteristic equation as z cube plus 3z square plus 2z plus k is equal to 0. Now, for this particular new characteristic equation, if you define Routh's table, the row corresponds to z cube 1 and 2, z square 3 and k, z power 1 element 6 minus k divided by 3, z power 0 element, that is k. So, for a new system in z variable to be stable, in other words, for the characteristic equation in z variable, roots to be in the left hand side, what is the condition here? K should be greater than 0 and 6k minus should be greater than 0. In other words, k should be less than 6. Therefore, you can define the range for k will be 0 less than k less than 6. In that case, characteristic equation for the new variable should be left side of its reference, or else characteristic equation for the original equation roots will be in the left side of -1. Therefore, from the given options, you can select option C, that is in the range of 1 to 5. It is satisfying 0 less than k less than 6. Okay, therefore, for this question, option C is the correct answer. Next one, there is a one state space model is given, MSQ. Here there is two answers correct. Consider a system S is represented in a state space form as some state space equation is given. So as per this state space notation, this is matrix A, this is B, and this is a C. Now, which of the state space representations given below has or have the same transfer functions as that of S? So what I can do now, I would see, this is a somewhat lengthy question. For the given system, I would like to find what is the transfer function. Okay, so for given system, what is the transfer function? G of S is equal to C multiplied with Si minus A inverse into B. Therefore, first I would like to find the matrix for Si minus A, that is S 0 0 and S minus A matrix 0 minus 2 1 and minus 3. So it will give you S minus 0, it is simply S, 0 minus of minus, so 2, 0 minus 1 minus 1, and it is S plus 3. So this is a Si minus A matrix. Next one, Si minus A inverse. So what is that? 1 by, now AD minus BC. Therefore, S square plus 3S plus 2, this is a determinant, denominator determinant. Now let us write down adjoint. S plus 3, interchange the diagonal elements, change the sign of for off diagonal elements. Minus 2, 1 and S. Okay, so this is Si minus A inverse matrix. Now C into Si minus A inverse into B. So C matrix is 2 minus 5, Si minus A inverse S plus 3 minus 2 1 and S. B matrix is 1 and 0. Denominator S square plus 3S plus 2. Therefore, how can we further simplify? 1 by S square plus 3S plus 2, and C matrix is just like this, 2 and minus 5. So here S plus 3 multiplied with 1, that is S plus 3 minus 2 into 0, 0. Therefore, you will have S plus 3. Okay, 2 by 2 matrix is multiplying with the 2 by 1 matrix. So the new order will be 2 by 1. Now 1 into 1 1 plus S into 0, that is 0. Therefore, it will be 1. Now the last step is transfer function for the given system. It is, if you multiply here 2S plus 6 minus 5, therefore you will get 2S plus 1 divided by S square plus 3S plus 2, S square plus 3S plus 2. Okay, now what I did here, for all of these 4 options, I calculated a transfer function by following the same procedure. If you have any new method or any simplified way to determine transfer function for the remaining systems, you please give me in the comment box. But I did transfer function for all of these cases. Out of that, I figured out for the two options, transfer function is matching with the given system transfer function. Now, transfer function, I will write down here answers. Transfer function for option A. Transfer function for option A, g of s is equal to, I got it, 2s plus 2 divided by s square plus 3s plus 2. Surprisingly, the examiner has given for the four options, determinant is the same, denominator is the same. Next, for option B, g of s is equal to 4 divided by s square plus 3s plus 2, and I found for option C and D, transfer function is 2s plus 1 divided by s square plus 3s plus 2, s square plus 3s plus 2. Now, if you observe closely, for option A and C, system matrix A is the same, but option C transfer function matches with the given system transfer function. For option B and D, again system matrix A is the same, but only for option D, transfer function is same as with given system transfer function. Therefore, for this question, answer will be C and D. Because of MSQ, multiple select questions, one or more than one options will be correct for the given question. Therefore, C and D are correct. So, these are the questions given in GATE exam EC paper from control systems subject. So, with this, I would like to say thank you for watching. I am Shankar. I am working as faculty at Home Institute, Hyderabad. We will offer coachings for GATE and various assistant engineer exams in the state board or national level exams, PSUs. If you are interested, you can call to the number given in the screen, or you can visit our website homeinstitute.com. With this, I will conclude. If you not yet subscribed my channel, please subscribe, and then you will get a notification whenever I am uploading any video. You can share this knowledge to your friends as well, just for educational purpose. Okay, in my YouTube channel, I am promising you, I will upload purely educational videos. Okay, after some time, I will also plan, once this PYQ is completed, I will also plan to upload some motivational or preparation strategy videos also. Thank you for watching.